Hey robot makers, hope you're having a good day so far. Got a bit of a blown out throat at the moment, so hopefully this is still audible and understandable. So yes, do you want to build a Raspberry Pi Pico W robot? And we're going to basically upgrade our Burgerbot so that it's got a Pico W in it, and we can control it using a MQTT broker, a mobile phone, and Node-RED. So my name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to the keynote and we can make a start on this. So yeah, unless you've been sleeping under a bush somewhere, you might not be aware that the Pico W was launched. Just grab one off my desk here. On Thursday last week. So that's what they look like. It's like the regular Pico, but it has a great big Wi-Fi chip on it there, meaning that we can do all kinds of cool things with our robot projects, such as remotely controlling them. So what we're going to be looking at today is we're going to be upgrading our Burgerbot. So Burgerbot is sat on my desk over here. This is what Burgerbot looks like, and it's got a Raspberry Pi Pico W now installed on the top, and we're going to do some other cool things with it as well to give it some much needed upgrades. So we're going to talk about the Lipo Shim, how we can add that in. We're going to talk about how we can create a dashboard that can create controls, so we can control our robot using Node-RED. I'm going to show you the small changes we've had to make to the Burgerbot code to make it so it's Wi-Fi controllable, and then we're going to do some demos as well. We'll also do a live stream Q&A after, but that's for the live stream audience only. That'll be cut from the pre-recorded show. Okay, so let's get over to first part. So Raspberry Pi Pico W, yes, like I said, unless you've been sleeping under a bush somewhere, you probably heard that this is a thing now. Hopefully you've all got one of these as well. There's plenty of them in stock everywhere. I don't think it's like the Raspberry Pi 4s. You can get hold of these, and you can also get hold of them embedded in various boards. So Chris is on the stream today, the inventor of this Inventor board, which is the Inventor 2040W, and that has a Raspberry Pi Pico W aboard. So it's kind of slapped on the middle of the board there with all the castellations, and it's got all kinds of extra add-ons. We're going to do a separate show about this one. It's too good just to include as a segment in the show. We're going to have a review of it. I'm going to do something with it robot-wise as well. So if you want to catch more about what the Pico W brings, you can check out in that little picture there on YouTube. You'll find that thumbnail, and I did a show all about that. A small show. Okay, so Pico W Robot. So what I thought I would do, in fact, when I envisaged Burgerbot, I had a Pico W, but I wasn't allowed to show it. I wasn't allowed to do anything with it. So I can now make it basically what I intended it to be in the first place, which is a completely remote control robot, one that can send back sensor data that it detects, and also react to commands from a remote location. So what we're going to do, we're going to add that wireless control, and it's very, very easy to do that. The Lipo Shim, we're going to have a look at that in a second. We've got a gallium battery pack, which is the battery which sits on the back of the robot. I think these are going to be available shortly, aren't they, Chris? I'm not sure if they're available just yet. But it's a small 400 milliamp hour battery, Lipo battery, perfect for robots. We're going to look at Node-RED sending a Node-RED dashboard sending MQTT messages via some slider controls. We're going to have a look at how we can build a user interface ridiculously quickly. And we're going to make those code changes to add Wi-Fi to our Burgerbot so it can respond to MQTT messages and potentially send back sensor data as well. That's probably for a later show though. So these are the upgrades. So the Lipo Shim, this is a Pimoroni product, and this enables us to connect a Lipo battery, like one of these, for example. This is one from the Badger that I had, and it has this GST connector on the end. Is GST PH, is it? Connector on the end, and that means that we can plug this into the Lipo Shim. The Lipo Shim can connect to the Raspberry Pi Pico W's internal electronics and basically charge this battery by that connector. There's also a really nice on-off button on the front there, and it simply just slides over the top of the Raspberry Pi Pico's headers, and then for a really good connection you want to sort of solder that in place. But I had quite a lot of success just sandwiching it between another board, which is the motor board that we're going to be looking at as well. So the gallium battery there, you can see that's a 400 milliamp hour 3.7 volt Lipo battery. It's in a hard case, so it's really protected. If your robot does some naughty things, it'll have some reasonable amount of protection on there. It's really small and really light, so ideal for this kind of thing. And there's the Pico W on the end there, again, just in case you're not aware of what these actually look like. Okay, so Actually, changing out the Pico was really trivial. It was just 4 nuts and screws I had to take out, put the Pico W in place, screw it all back into place. That was pretty straightforward. And one of the things I needed to do to fix the upgrade, I shall show you what I had to do. So on the back of this Burgerbot, you'll see that there's like a flat panel there, and that's underneath there is where the connector is for the USB. If I can get that to show there. And one of the problems is when I try and put a USB connector in there, because it's so flat against the top surface, you can't actually get the cable in. So what I've had to do, I had to create another one, of course. So I've created a small indentation in the top there, which means that the cable can now go in much simpler. But it does mean I've got 2 Burgerbots now to play with. And we'll have a look at what we can do with both of them shortly. So that's one of the small changes I've made as well. So this is one of the shims. This is the Lipo Shim. You can see there it just sits over the top of the pins. Very easy to add extra features to your Pico this way. And they slide just over the top of the pins. Like I said, they're stackable, so you can put other things on top of that as well. To a point, I mean, you can't have infinite amounts of these stacked up, I guess, but this one can also be used with the motor shim for Pico, which is another Pimoroni product, but it just means we can plug in some motors very simply with some little connectors. I think are they JST ZH connectors, Chris? I think they're very small connectors anyway. And the Lipo Shim provides battery charging via the Pico's USB connector. So really nice ecosystem for it to live there. It means everything's kind of self-contained. So if you like what I do and you want to help me out, please make sure you give this video a like. Drop me a comment. Let me know if you bought yourself a Pico W or how many of them you've actually bought and what you intend to do with them. And also, if you've not already subscribed to the channel, now is your chance to hit that bell and get yourself subscribed. And I do go live every single Sunday, even when I'm not feeling 100%, I still go live for you guys and show you something interesting to do with robotics. And I do that at 7 o'clock UK local time, so we're in British summertime at the moment, so it's GMT +1, but in the winter months, it'll just be GMT. Right, we said we would talk about Node-RED. So Node-RED is a piece of software which allows you to connect Internet of Things together. It's really simple. It's very straightforward to install as well. A lot of Raspberry Pis come with this pre-installed. I prefer to install this via Docker so that I can just have it installed wherever I want it to be and not have to worry about that element of it. And then actually configuring things, you just drag things off a palette on the left-hand side, connect the things together with little noodles, and then you sort of double tap or double click on the thing itself to open up some settings and configure from there. And you can do so many things with Node-RED. You can launder your data from one format to another. You can respond to triggers. You can create home automation systems. The lot. It's really cool piece of software. So I use this to connect to my MQTT broker, which is running in another Docker instance. And we'll talk about MQTT quite a lot in these projects. We did do a show on that a couple of weeks ago, so if you want to catch up on what that's all about, just look for the one about home automation and you'll find that. So it's the drag and drop interface. We're going to have a look at it in a minute. I'm just talking about it very briefly here. And it can be accessed via mobile phone. Because it's just a web page, we can connect to that same web page on our mobile phone, and that means we can remotely control our robot as long as we're in range of our Wi-Fi, and that's connected to the same Wi-Fi too. So you can see that in the top right there, that's the sort of noodly diagram. That's what we do to configure Node-RED. And then on the picture on the bottom right is the actual output of the user interface. It's got some nice slider controls, and I've also got some little half donut controls, I think they're called, gauges, just to show what the current value of that is. And they're really dynamic. They respond to whatever the value is of that message from the MQTT broker. So we can use this to send and receive everything, and then use Node-RED to visualize and also provide controls for our user interface as well. So we're going to build out that in a second. In fact, we're going to build it out now. Let's do that right away. Okay, so I'm going to just go back to me for a second while I get the right page up. And we can head over to Node-RED. So I'm just going to create a new page there. Here we go. Okay, so I'm just going to close these other tabs I don't need open at the moment. So let me just move that other window out of the way that you can't see. Right, so this is my Node-RED instance. On the left-hand side here, you can see I've got these nodes that we can pull out and we can put onto this sort of canvas area here. So the first thing we want to do is we want to pull out, we're going to get an MQTT out node, I think. The other thing we would want as well is an inject node. And I think will that do for now? Right, yeah, let's just connect those up. So I'm just going to connect that up with a little noodle. I'm going to double click into here and we can say what kind of message. So it's just sending a timestamp by default. I'm actually going to change this to a value of 0.5 and let's call this 0.5, and then the topic is the place that we want to send this message to. So let me just take my watch off so it doesn't click on the microphone there. So the first thing I'm going to do, I just move that up there, is just type in the name of the topic. So it's going to be robot. I'm going to go robots. I'll check that that's the right one in a second. So robots / Burgerbot, and then let's have left motor. Okay, so let's just update the name of our thing. So that's left motor 0.5. Okay. And then for our MQT, we're going to double click into that. It already knows the name of my MQTT broker, and it's got a test account, so that's fine. And then the actual topic that we're going to send it to is robots and Burgerbot left motor. Let's just copy that as well. I'm just going to mute myself a minute while I just cough. Okay, good to go. Right, so I need to deploy that. So that's going to make that now live. So if I now click that button, what's going to happen over here, and we can click on this little debug thing to see what's going on. If I click on that, it's going to send a message on that topic. So what I want to do, I'm just going to go back to my other page where I just created some previously. I've got robot, there we go. So let me just make sure I've got the right one on our new one. So let's just go in there and change the topic to robot, and similarly in here, are we going to output there? Actually, let's just take out the topic and just leave that in and then deploy again. And I'm just going to click on there. Okay. Right, so at the moment that's just sending that out to the actual broker. Now I want to see what messages are actually happening. So I've got this debug node, I can bring that out, and basically every message that we send to here, we can also send it to our debug node, which appears over here on the right. So if I now click on that after deploying it, you can see there that it says robots Burgerbot left motor payload is 0.5. So let me just double click and make sure that's right. I missed out that little slash there. That's why I wanted the debug node, to make sure my messages are correct. I'm just going to deploy that again, and then I'm going to press that little insert button again. Right, that looks correct now. That's kind of what I was aiming for. So we can create lots of these for different things that we want to send our robot. So I'm thinking I want to send the motors left and right commands, either full forward or full reverse. And it's going to be a value between 0 and 1 or -1 and 0, depending on which direction we want the motors to turn in. And we need a pair of these, if you like, for each motor. So if I just copy and paste that and then double click and change this to right motor, I can come over here and I can just remove that and change that to right motor. And I can then, let's just copy that as well. Plug that noodle in, change, and that's not, oh, that has got a name. I can actually get rid of the name. We don't actually need the name in there. That can be a bit confusing actually. Let's get rid of that. And if they're actually going to the same location, we can actually just use the same node like that. Oops. That means we can get rid of that. Okay, so let's deploy that and let's press some buttons. If I press the left one, we can see the left motor gets 0.5. If I press the right one, we can see that the right motor gets 0.5. So that means that we can send and receive messages very simply using MQTT. It's not going in, nothing's receiving yet, nothing is subscribed to that. So what we can do as well, I've installed some extra dashboard nodes. So the way that we do that, we go to, I just moved me out the way for a second, we go down to manage palettes, we go to install, and if you just search up dashboard, I think I'm using that one there, Node-RED dashboard. So make sure you've got that installed, and then you can you can do things like sliders. Okay, so what I'm going to do, excuse me, I'm now going to put that message into the slider, and I'm also going to put that back out to our MQTT, and we can remove that middle bit there. So that's kind of the left, the right one. We need to duplicate that, so cut and paste, and then do the same with the left one. Put that into the little output there as well, and then I'm just going to double click on it and set some settings. So so this first one is, it's going to the left group, so let's call this one left, and the value is between -1, 1, and it's going up in steps of 0.1, like so. And the output is going to be continuous while sliding. That's important that we've got that. And then I've got that plugged into the wrong one there, so that should have been the right one. Let's just change that so that's right. This is just a name at this point, so it's not doing anything else other than providing the value. So let's just change that. I'll tell you what these groups are in a second, don't worry. So the label was left. The value was -1, maximum 1, steps of 0.1. Okay, let's deploy that. Now what's happened is when we drop things onto a dashboard, if we go over to the, I think there's a dashboard setting on here, there it is, dashboard, we can create different groups and then areas to put those controls in. So let's create a new area, a new tab. Let's call this one live tab, just so that we can see what we've created. Okay, let's update that, and then what I need to do is just double click into these and make sure they're on the correct dashboard. So let me just find that. If I just do a new dashboard group, select the live tab, leave it as default, that's fine. And what I'm going to do as well, let's create a new group that's called like the left and a right group. So let's do a left group. It makes sense because of the layout. In a minute you'll see why that is. So if I just do left, and then let's do a right as well, right group. Okay, so if I now put the left one in the left group, I think I didn't quite do that, did I? There we go. Okay. So left is in the correct live tab left group, and right is in the live tab right group. That's fine. Okay, deploy that. And what I'm going to do now is I'm just going to go over to the new live tab. Yep, there it is. So we've got left and right. So as I move these, we're actually getting values sent to our MQTT broker. So what we can do to actually visualize that, we can put little gauges down just to show that that's actually happening. So if I go back up to MQTT in, and I just grab some gauges, let's just find a gauge. There we go. That's the sort of half donut thing, and then I just noodle that. Left motor. Okay, let's put this on. Okay, deploy. Excuse me, sorry, I didn't mean to do that on live. Right, so at the moment that's not sending, so let me just debug that. So let me just check robot Burgerbot, left motor, and let me just check that we are getting the correct values there. So now let's just change that range, so -1 to 1. Let's try publish that again, see if that makes the difference. There we go. So now it's still not actually sending the commands, because we should be able to see that feeding back. So let me just make sure I've got the right one here. So that's an MQTT in node. So robot Burgerbot left motor. Let me just make sure that is what's being output there. In fact, robots, is that the problem? I've put robot instead of robots. Yes. Okay, let's just go back to there and just add the S. The intention is that I can have many different robots all sending, and they would have their separate names. Right, let's go back to the dashboard and let's control that. Nope, still not working as we expect. Good grief, let me just double check. Left motor, output, detect string or object, that's fine. The actual gauge looks fine. I'm just going to go back to my other page and see what I'm doing wrong there. So this is the kind of finished one. So we've got a slider. So what I'm doing is I'm actually outputting it from the slider. That's what I need to do. So let's go back to our example. Let's get rid of that there. And let's put this as the output. So let's do that as an output there. Let's copy and paste that and make that the right one. So let's call that one on the right, and it is the right motor. Okay. That is left motor. Okay, I think we're nearly there. Just need to make sure I've got the units correct. Yep. Deploy. Okay, let's try again now. There we go. So as we're sliding from the very left to -1, the middle is 0 and the right hand side is 1. Right. So this is the control that we're going to use to do the left and right motors. So what we need to do is we need to make sure we can control the motors at the same time. So it might be easier to have like a backwards and forward slider as well, which basically just overrides the motors and makes them turn in the correct orientation. So we could do that just by outputting the value of 1 and send it off to 2 different nodes, or we could write in our code that if it receives a direction forward message instead of being on the left or right motor channel, that's another way that we could handle this. But I think we're quite happy with what we've got there. We can double click to rename this node as well. So that's the live robot control. Okay, deploy that. Okay, right, so that's the code. Let's go back to our keynote. And we need to update our Thonny code. So let's have a look at that, shall we? Just going to go over to Thonny. Wrong one. Okay. So on our Burgerbot, we need to have a couple of files installed. So we need MQTT simple. That gives us the ability to send MQTT messages. We need Burgerbot, which is the Burgerbot code. I'm sorry, I'm really struggling with my throat today. I might have to wrap this up shortly. And we have MQTT, Burger MQTT, which is here. Okay, so we connect to the broker. We provide an IP address for the broker. We need a client ID, and we need the message for the left and the right motor. Okay, let me just have a look. What I'll do, let's go over to the overhead. Okay, so I've got the robot here. We have the motor shim installed on top of the Lipo shim. I can just show you that. So there is the Lipo Shim with a little battery dangling off. And there is the motor shim on top. Now if I press this button here, it's going to light up and there's going to be a little LED that's just under that corner there. You'll see it start flashing there. When it starts flashing at 1 per second, that actually means it's connected to our Wi-Fi and it's ready to go. So I think it's still trying to search at the moment. And when it's happy, it will start to flash 1 per second. If it doesn't do it, I might just switch it off and then on again. Let's just switch it back on again. And that's just the onboard LED of the Pico. And the code there basically just says flash at 1/4 of a second. There we go. See now it's doing 1 per second. It's now connected to our Wi-Fi. I'll go through the code in a second. I just want to give you a bit of a demo while I can. Okay, so what I'm going to do, I'm going to go back over to our dashboard. Go to this dashboard, and in fact if I go over to, let me see, this view, there we go, we can sort of see both things at the same time then. Right, it's quite fast, this robot, so what I might do is just put it, well, I'll leave it in the middle and then we'll just slowly control the motors. I'm going to do direction first. Let's see if it picks up on this. Let me see. Make sure I've got everything properly in place there. Right, let me just switch that off and on again. It doesn't seem to have connected properly there, even though it said it had. Let's just try that one more time. So it's flashing, which means it's connecting. I can see it a bit easier than you. And then we've got this solid one, so now this is frustrating. This was actually working before. I'm using the other interface that we created. Let's go to the live one and just see if that does anything differently. No. And we can actually check on our debug thing as well to see. Okay. So probably topic selected. That's on the one that we built. So let's go back to the Burgerbot one and let's see if we now go and start sending some commands to this. Let's try. Subscriber there. Let's try just pressing that. So robot, Burgerbot, right motor. Let me just check everything is fully pushed in and connected. This is so frustrating because it was actually working before. Let me just try one more time. Unless the battery is flat, that may be an option actually. Let's just that's probably what's happened actually. So I've got a spare battery we can just try. I'm hoping this one's charged up as well. No, of course that one's flat as well. Okay. So what should we do? What should we do? Let us try. Let's try another battery. Let's try. I should have tried these before we went live. No, that one's flat as well. Okay, let's try something else. Okay, that's got power. Okay, let's see if this will actually work. It's not quite as elegant as the small one. Okay. Right, okay, that's flashing as if it's connected. Let's go back over to our dashboard. Let's try sending some commands. No, and of course I've not put that in the right place. Okay. Connecting one more time. Back to our home tab. That's probably what I was doing wrong, actually. Okay. This is completely a power issue at the moment. This battery that I have, these 2 power, for some reason it will cut out after a while. I don't know if Chris, you've ever experienced this as to why this actually happens, but unless you press that button, it doesn't seem to actually provide power. It will come on for a couple of seconds and then it will go off. What I will do, I will find a regular USB power, and we'll go from there, because that's probably going to be our best bet. Let's find a suitable cable. Of course, this is the robot with the wrong connector on. Let's try this one. See, I'm not sure if I've got the right code loaded on this robot. That's the only thing there. Okay, so okay, let's see if we can get that to work. No. Oh, actually, is that actually working then? Okay, so let's try something else. I'm going to plug that back in. I'm going to load the code from the computer onto the robot. This is not as slick as my normal live streams, is it? What's going on? Right, so what I will do, I'm just going to press stop so we can connect to the Burgerbot. I'm just going to make sure it's got the latest versions of everything that we need. So there's a secret.py. I can talk through the code now, actually. So we're bringing in quite a few different bits and pieces here. If I just bring this down here, we're bringing in Burgerbot, which is a piece of code I've written which replicates all the functions of what I want Burgerbot to do in Python. So I can just bring that through as Burgerbot down here, and then I can just use the bot thing to do like bot.left, bot.right. We're bringing in secret, and that brings in our SSID for our Wi-Fi, and also password, which is our Wi-Fi password, and that's kept not securely but secretly down here on our Pico W. I don't have that in the GitHub, so people don't get to know what my Wi-Fi password is through here anyway. We bring in MQTT Simple and the MQTT client. That's the thing that's going to enable us to send and receive messages in Python, in MicroPython, in this piece of code. I can't remember who wrote that, but that's something I've found on the internet. It's a really great piece of code. We're then bringing in the pin from the machine, and we're bringing in network, and network is the piece of library. This is the library that will bring in all our networking functionality. And then bringing in sleep and ticks, microsecond or millisecond, whichever one that is. And then creating a variable that's called MQTT broker, and we're going to set that to be my local MQTT broker. I don't use a username and password on that one because it's a test one that only I can access. I give it a client ID, and that's when it's connecting to the MQTT broker, the broker understands what's connecting to it. It just gives it that nice name as Burgerbot. And then got 2 topics, robot/Burgerbot/left motor, robot/Burgerbot/right motor. We then do the bit that connects us to the Wi-Fi, so I create a variable called wireless LAN, WLAN, equals network.wirelessLAN, network, and then that's static interface, something like that, or station interface. We then do a WLAN.active, we set that to true, so we make the interface true, and then we connect the interface by giving it the Wi-Fi username and password, which is just slightly off screen there. I then create an LED, which is that LED that flashes our status, and we set that to on. Then we create Burgerbot, just create a variable called bot. And then there's a couple of functions. So I'll cover these off on the pie chart one before. It's the exact same bunch of functions, really. So we have a subscriber callback, and that's just a way that MicroPython is handling the MQTT subscriber messages. So every time a new message comes, it will run this piece of code. So what we're going to do, we're going to decode that message that comes in. UTF-8 just means it's like 8-bit characters, like A, B, C, D, E. They're all represented by 1 byte. The topic is also decoded, and then we can print them out just to see what the actual messages are that we're getting through. And if the topic is left motor, then we print out move left motor, and we say bot.left motor, and then pass in the message, which is the value. And because that message comes in as like a text string with those little speech marks around it, we need to convert that, we need to typecast that to be a floating point number, a number between 0 and 1. So it might be like 0.1 or -1 and 0. And similarly, if topic is right motor, we can then say right motor and then the value that's come through as well. The next two are the things that connect us to the Wi-Fi. So we've got lots of different functions there. We essentially create a client object and pass it all the bits and pieces we need. We subscribe to the left and the right. And then we have another one, which is what to do if we get disconnected, and essentially we just want to reconnect. I'm not sure this is a great piece of code, if I'm honest. On the original version, it had machine.reset, but because I hadn't got this running as main.py, machine.reset would just basically dump it back out to the REPL, and I'd have to run this again. So I've just changed that to client equals connect and subscribe. The problem with that is it might end up creating, like, might run out of memory, and we'll have to reset the robot. So that's something I need to come back on and do some checking on. Okay, so the next thing I do is I create a little timer variable, set it to be whatever the current ticks in milliseconds is. I then say connecting to Wi-Fi, and then there's a little loop that says while connected is false, do this thing. So we then say the current time is ticks ms. We then check to see, is the difference between those about 1/4 of a second? If it is, we then toggle the LED. So if it was off, it's now on. If it was on, it's now off, which is how we get those nice quick flashes. And then we say print connected once we've come out of that loop, because connected is true. We can then print out what the Wi-Fi IP address and all the DNS and router details are. Then finally, we can then say, try client equals connect and subscribe, which connects to that topic that we saw earlier above. Let me just move this up a little bit so we can see what the rest of the code is there. And then we've got this little while true loop. So we check for new messages. We set that current time. We do that timer thing again. And again, this is just to flick the LED on and off without having like a sleep function. Because if we had a sleep, then our robot would basically be asleep for that amount of time and wouldn't respond to new messages. So this is purely a way of capturing what the current time is, checking to see if it's 1,000 milliseconds or 1 second between the last time it updated. If it is, we then reset the timer to the current time. We print out what the current time is, and we toggle our LED so we get this flashing on or off at 1 second intervals. If we have an error, we just say restart and reconnect. So what I'm going to do, I'm going to upload that as main.py. So if I go to save as, save it to the Pico as main.py and click OK. Hopefully, when we now just give it regular power, I mean, we could just run this as a Burgerbot actually. So let's see what happens down in the REPL there. So it's connecting to Wi-Fi. And if we look on the overhead there, we can see that it's flashing very slowly now. So it has connected, and it's looking to see are there any messages coming from our interface here. So if I move some of these, there we go. So that wheel is now turning. What I'll try and do is get one wheel to turn in one direction and the other to turn in the other direction, and it should go round in a circle as fast as it can. If we now just use this direction instead, let's set that back to the middle, and I just make it go forwards. Oops. I don't know why it's dissipating off the screen. If I just click there, that's backwards, there's forwards. Because I've got the USB cable on, it's kind of holding it back a little bit there, but you can see it's trying to go forward. If I move that and go backwards, it'll then come backwards. and if we put that to the middle, it'll stay at the middle. So let me just give that a reboot. Turn it off and on again. So sometimes it does seem to get disconnected, and then it will carry on doing whatever the previous message was. So if that message was like 100% forward, it'll just carry on doing that. Now, one of the cool things is if we have two robots listening on the same topic that have both got power, and I don't know whether I've got, if that battery is going to work on this one. Let me just see if we can get this to work at the same time. They will both respond to the same messages because they're both listening to the same topics. Now, I'm not sure if this is going to behave because I think that battery was on its way out and needs a good charge. I have been playing with it throughout the day, so that's probably why. I think that one is definitely gone. That's a shame. I wanted to show both at the same time. Cool, cool. So you can see there we can actually access this now using a mobile phone because this is a web browser. This means I can pull out my phone. I can go to that exact same address that we've got up there. So if I just find that IP address, so let me just type the right one in, 168 1 dot, and we're on that 1880, and then slash user interface, it's just slash UI. So I've now got the exact same interface. Now what's really cool is if I start playing around with this, if I go to that home tab there and I start dragging this back, if you can see on, in fact if I do it on the overhead it's probably a bit easier. If I move that slider there, can you see it's actually moving the right motor on the web browser that's down there? If I grab the other one, which is direction, and I pull that back, that controls all of them. So because these messages are all being sent and received to the same MQTT broker, and there's lots of different clients all subscribed to it, they can all respond. And we can see there that it's getting that on both my mobile phone, so I can basically use this as like a remote control. Now, one of the caveats is if I try and move both sliders at the same time, it doesn't actually let me do that. This is because it's not a multi-touch. Browsers aren't multi-touch. So I need to figure out a way of doing that. And that's why I created that directional slider, which grabs hold of both of them, like so. So if we go back over and let's have a look. See if we can stop. Now I have had this as well, because the version of MicroPython that we're using is quite bleeding edge. It does misbehave a bit as well. So if I try, I've physically connected to the robot with a cable, but when I click the stop button in Thonny, it basically just ignores me and doesn't let me continue. And I can hold down the button, the reset button. Doesn't make a difference. It won't actually let me do that. I'll have to actually flash the nuke image onto there, which wipes all the RAM, and then load up MicroPython once again to actually get that to work. And I think that's just a bug of the version of MicroPython, which is just like the bleeding edge version that's on here. Which if I scroll up, we can probably find which one that actually is, if it's captured that in the buffer. There we go. So it's that version there, 99C2589, and that's the launch day Pico software. And this is also the version of MicroPython that's the batteries included Pimoroni version as well, because we're using the motor shim that has some extra functions in there that we're using in the Burgerbot code. So if I load up the code, we actually use motor, which is the Pimoroni batteries included MicroPython. So I'm sure that'll get sorted out in the fullness of time, but this is all quite bleeding edge stuff now. We've been able to see there, I'm afraid the batteries didn't work quite the way I wanted to, and that's because I've been using them throughout the day and they've sort of run out of charge. And I think my throat has run out of charge as well. So that's what I wanted to cover off in the demonstrations. I think that's everything. The other thing I wanted to just basically say as well, if I just go back over to the keynote, is if you've not joined our Discord server, you can head over to action.smilesfan.com/join-discord, and you can join the conversation that's going on over there, where we talk a bit more about robots and so on. I think that's all it for the slides. So yes, if you're watching this live, we're going to continue the Q&A for as long as I can. And if you're watching this on replay, this is the point of the video where I'll say thank you so much for watching, and I shall see you next time.